as I was explaining you earlier, once this stream has been defined and the amount of the pressure and temperature that we have calculated has come over here, so we just copied this stream into the 10 different wellheads. So 86, 87, 88, 89, all these numbers that you are seeing over here are defined by the 81, and then they commingle together at a production header. This production header is of usually of, it depends on the condition, it is usually of 12 inches, 16 inches or 20 inches depending on the amount of the oil that we are having based on the hydraulic velocities. So basically what we do is we calculate the hydraulic velocity across that production header, and based on the standard API 14E, that how much velocity limits are for the 12 inches or 18 inches if it is a multi-phase or the single phase liquid, gas or the water. Based on those calculations we define it that whether it can be a production header of 12 inch, 16 inch or 20 inch. So all these values are mixed together here, and then it goes all the way from this production header and it goes to the different line. This is a subsea line, it can be of to the size of the 24, 30 or 36 depending on where we are tying in that particular wellhead. So there are two more streams that those are adding in this particular line. So I'll explain you about these two lines later on, but this goes all the way to the mainstream. As you can see, here is a name known as the ZV, that is the emergency shutdown valve, that is upstream of the pipeline. This is your basically emergency isolation valve. This emergency isolation valve acts in that case scenario through the ESD system, that if you are having an overpressure case scenario, so in that case scenario this ZV will activate itself, it will turn off and it will not allow the fluid to pass through this. For example, still the overpressure case scenario keeps on building. In that case scenario, your these two valves, the SSV and the triple SV, they will activate. As you can see, you will see I haven't shown the pressure indicator and the temperature indicator over here. So after the choke valve there are pressure indicator and temperature indicator as I am indicating on the video. Same is the case scenario for the upstream of the choke valve. So you'll be having the pressure indicator and the temperature indicator. The pressure indicator that we are using over here will be the Borden type gauge, the spring one, and the temperature indicator that we are using over here are RT, this is the resistant temperature devices. Same is the case for the downstream. In the meanwhile, when they are mixing together, all production header and every single pipeline will be having a pressure indicator and a temperature indicator at every single time, at every single pipeline, depending on the distances and the standards. Another thing that I was actually explaining you regarding about these two systems is that the first system that I am circling is the storm run of water. So all the water that is coming to the wellhead platform is going to one of the vessel over there that is known as the slops caisson or the tank, that is going to the slops caisson or a tank, and that tank is connected with the pump. The pump is taking that water and it is re-injecting it into the line just before the ZV. So upstream of the ZV you will be having a tie-in of the slops re-injection. This tank you can see over here is another system that is known as the chemical injection system, that we usually inject the chemical just to avoid the corrosion, because it is a multi-phase flow. So in multi-phase flow what happens is that if you are having a high amount of the gas, in that case scenario your liquid becomes stagnant at the bottom of the pipeline, and the debris those are coming out of the reservoir, that is usually in the form of the mud. Those mud debris they will